Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the difference of the velocity at any point and average velocity for smooth and rough pipes. So these are the things already have discussed in our previous video lectures. One thing we have discussed the velocity at any point. Another one is the average velocity we have already discussed. That velocity at any point and average velocity for smooth and rough pipes. Okay, so these things already we have derived previously. Now we'll see the difference between these two. So let me give you a glimpse of what previously we have discussed. So this is the pipe is there, and through this pipe the fluid is flowing with a velocity of u, and velocity at any point in that portion, this is not required. Elemental circular ring is not required. Normal fluid flow will be there, and at that point we need to find out the velocity at any point. And there we need to consider near to the wall surface our velocity will be 0, and it will be maximum on the center point of that. So here also the same thing, like this is velocity at any point. For average velocity, we need to consider this circular ring, and we need to consider the radius of this circular ring and the total radius of this pipe. Okay, then the distance between from here to here, and we need to find out the average velocity here. Anyway, so these things already we have discussed previously. Just to see the differences between these two velocity at point and average velocity. So let me write first thing, the velocity of the fluid at any point. This one we have already discussed. At any point for turbulent flow. Okay, this all the things are we are discussing for the turbulent flow only. For turbulent flow, and first one we'll consider, see, in the turbulent flow also we have two equations. For one smooth flow is one smooth pipe, another one is rough pipe. This, what is smooth pipe, what is rough pipe, also we have discussed in our previous video lectures. You can visit that one. Anyway, turbulent flow, here I can write for smooth pipe. Okay, now let me write this equation. What we got, u by u star equal to 5.75, and this is log 10, and this will be here again u star, and this will be actually y. Okay, y by nu plus 5.5. okay, now at this point actually we need to consider like the value of y equal to, we know that capital R minus small r. That means the radius of this pipe and this radius of this circular ring. So this is y. So you can put the value of y here, and we can find out the value 5.75. This is log 10, and this is u star into capital R minus small r divided by nu plus 5.5. So this is the equation, the velocity of the flow at any point for the turbulent flow in the smooth pipes. Now for the same condition, like for the smooth pipe, what is the average velocity we got there? So again we need to write the average velocity for this smooth pipe, average velocity of the smooth pipe in the turbulent flow only. So there we got u by u star. This is a lengthy equation actually. U by u star. There we can write, so this is on behalf of this 1.75 will come. Remaining will be as usual, like 5.75 log 10, and this will be u star capital R by nu, and this is plus 1.75. This one we got for the average velocity. So here is the average velocity here. This is actually average velocity. Okay. Now this one we can give equation 1, which was already derived previously. This is equation 2, which also we have derived previously in the last video lectures. So there you can see these two equations. Now what they told to identify, now we need to identify the differences between this velocity at any point and average velocity. So the differences we can write. Now let's write the differences between u and u average of smooth pipe. Okay, so simple things we can, what we'll write, what are the equations are there, just will copy paste that one. U by u star minus, this is u bar by u star again, equal to this value, right, 5.75. this is log 10, and this is u star r minus small r divided by nu plus 5.5. now minus of this, so we'll write this minus 5.75. this is log 10 again, u star r divided by nu minus 1.75. now this is all total. So what we'll do here, we'll take this log term one side, this 5.75, this log term one, this one, and this one will keep it one side, and this numerical value will keep one side, like means we'll take nearby. So what we'll get here, so 5.75 log 10 we can take common, so 5.75, this is log 10, log a minus log b, so we can write log a by b. So bracket start, that means u star r minus r divided by nu, and this is divided by this one, u star r divided by nu, bracket close, and this one will be minus 5.5 minus 1.75, so it will come like 3.75. okay, now again we can solve this equation dividing this, like this divided by this, if you do, then we'll get like 5.75, that part will be cancelled here. If you see, u star will be cancelled here, nu will be, nu by nu is there, so that also will be cancelled, this will be cancelled. So what will be the remaining things, square bracket r minus r divided by r, bracket close, minus 3.75. so this is the differences between this, or else we can write again in a final terms like u by u star minus u bar by u star equal to 5.75, this is log 10 bracket start, r minus r we have taken y here, so the same thing we can keep it otherwise here, y by r 3.75. this is very simple, just we need to subtract the terms from the velocity at any point and average velocity. This is the final one. So this one we can give equation 3. This is for smooth pipe. This is for smooth pipe, average velocity for the smooth pipe, and this is the velocity at point for the smooth pipe. Similarly, we need to find out for the rough pipe. There is no other differences are there. So for here also let write similarly velocity at any point. So these things no need to write. I can directly will go for the at any point for the turbulent flow, and for rough pipe we can write here for the rough pipe. So is known as, we can write U by U star equal to 5.75, and this is log 10 bracket start y by k plus this is 8.5 per there. Okay, now here also you can put the value of y equal to r minus r, or we can keep it the same thing, no issue. Now this is velocity at any point for the turbulent flow when the pipe is rough condition. Similarly, we need to write again the average velocity of rough pipe in the turbulent flow condition. Again, same thing. So here also we just what we'll do, U bar by U star equal to, we can write the equation what, 5.75, this is log 10 into here r by k, we got r by k minus r by k plus 4.25 actually, plus 4.25. This was the equation we got for the average velocity when the pipe is rough and when the flow is turbulent flow. So this is U bar by U star equal to 5.75 log 10 r by k 4.25. Now very simple again. So this one we can give equation 4, and this one we can give equation 5. Now what is our motto? We need to find out the differences between these two. So the differences between U and U bar, that means the velocity at any point and the average velocity. So we can write here, let it write. So U by U star minus U bar by U star equal to, same thing, just to copy paste this equation what we have written here. See, 5.75, this is log 10 and y by k minus plus 8.5 minus 5.75 log 10, this is r by k minus 4. This is 25. Here one more thing, what we can write here on behalf of writing this one, we can write U star in the denominator, and we can write U minus U bar directly, U minus U bar by U star, and this equation we can write directly also. So here also we need to do one thing, as a log part will consider in one side, and this numerical value will take it to one side. That means this 5.75 is log 10 will be taken as a common, and here we can write this is y by k and divided by this is r by k. This is r by k bracket close, and 8.5 minus 4.25, which will be 8.5 minus, yeah, it will be near about 4.25 I hope. Anyway, so what the value will be will get here, let identify this. So 8.5 minus this is 4.75, yeah, 3.75. This is actually 4.75, not 4.25. Okay, now we can write this 3.75. Just you divide these terms inside here, so we can see our kk will be cancelled here, and here finally let me write here U minus U bar divided by u star equal to 5.75 log 10 bracket start y by r plus 3.75, and this is our final equation for the difference of this velocity at the 1 point and the average velocity for the rough pipes. This is the final equation. So equation 6 and this equation 3, these are the final two equations for the differences between this smooth pipe and the rough pipes. So this can be used for anywhere. Now very simple things. Let me again just give a brief on that. So where I have taken this equation, so our discussion is here to find out the differences of the velocity at any point and the average velocity for smooth pipe as well as for the rough pipes. So average velocity means what is the average velocity which is flowing, the fluid which is flowing inside the pipe. We need to identify what is the average velocity. Here one velocity at this point is 0, here velocity different, here velocity different, so all the point velocities are different. So what is the average velocity at any point we need to consider, and what is the velocity at any point. So velocity at any point we need to consider, and average velocity. For to identify the average velocity, we have taken this one like elementary circular ring, and we have found the average velocity. And the velocity at any point already you have derived previously, and we got there u by u star equal to 5.75 log 10 u star u by nu plus 5.5. So this equation we got previously, where only you have derived for the velocity distribution for a turbulent flow in smooth pipe case. So this is all about what I'm talking about, smooth pipe, when the pipe is smooth. So how we know the pipe is smooth? When the k is, that means less than the delta star. Okay, k is nothing but the roughness, this one, irregularity of roughness. Okay, this is k, and delta star is the laminar supply. These things already have discussed in our previous videos. Okay, now for this that condition we got this equation. Okay, so here the terms, I hope you know, u is the velocity, u star is the shear velocity, and y is the distance from the surface to that, and nu is the kinematic viscosity, and this is for the velocity at point. Similarly, average velocity for the smooth pipe, this one we have discussed in our last video lecture. And what is the average velocity? U bar by u star equal to 5.75 log 10 u star r by nu plus 1.75. This equation also you got the last one. So next is the differences between these two. We got recently. That means what is the difference of this minus this? So we got here 5 point, these are the values, just to minus it, difference of that we'll get. So here if you see, okay, here actually plus will come, not minus, because the term is there. This is 5.5 and this is minus 1.75, so it will be plus only, not minus. Anyway, so this is our final equation for the difference of u and u bar for smooth pipes. Similarly, for the rough pipes, velocity at any point for the rough pipe condition, this is the equation. Again, we have derived in the previous video lectures, where you got u by u star equal to 5.75 log 10 y by k plus 8.5, and this is the average velocity for the rough pipes. Okay, this is 4.75. Now just we need to identify the differences between this equation 4 and 5. So this is the final equation of the differences between the velocity at a point and average velocity for the rough pipe condition. So I hope you understand this lecture video. If you are having any kind of doubt or query regarding this, you can give a comment on the comment box. Thank you all.